Welcome to GATE class. So today we will solve some problems related to continuous time system and discrete time LTI system. So let us discuss this problem. So xn is given, xn, that is input to discrete time LTI system. So xn is given as alpha raised to the power n into un, and the impulse response is given as hn is equals to beta n raised to the power n into un. Now the question is find out the output of the system, output of the discrete time LTI system. So the solution of this problem is yn is nothing but xn convolution with hn, and it is equals to summation k is equals to minus infinity to k is equal to plus infinity xk h n minus k. Now let us plot xk. So what is xk? Let us plot xk. So xk is nothing but also that alpha and beta is less than 1. It is alpha and beta is less than 1. So we have this xk, that is at n equals to 0 it is 1, at k equals to 0 it is 1, and then it is decreasing. It is decreasing. So this is our xk. Then we have hk. So hk is also decreasing. Hk is also decreasing like in this way. Then we can plot h minus k. Then h minus k. Then h minus k is behaving like this. That's it, because it is a time reverse. So h minus k is like this. Now there are two cases. First case is we need to find out h n minus k. So the first case, when n less than 0. So when n less than 0, so we will get shift at nth position. So it is 0, and there is shift of n. And when n is greater than 0, so the hn minus k is nothing but you have a shift in positive side. You have a shift in positive side. So we have a shift in positive side. So this is our graph. This is our graph of h minus k. This is hn minus k, and this is hn plus n minus k when n greater. This is hn minus k when n less than 0, and this is hn minus k when n greater than 0. So basically our requirement is graph of xk. So our requirement is graph of xk, hn minus k when n is less than 0, and hn minus k when n is greater than 0. So this is a graph of xk. This is graph of hn minus k when n is less than 0. This is graph of hn minus k when n is greater than 0. So if we see that, let us analyze these two graphs. If we can see that xk and hn minus k do not overlap when we have n less than 0. So if we analyze these graphs, then we can say that this xk and hn minus k will not overlap when n is less than 0. And we can see from these two graphs, we can see from these two plots that xk and hn minus k will overlap when n is greater than 0. So let us do that. So when n less than 0, let us consider the first case when n less than 0, that yn is equals to 0. It is simply equals to 0. Now when n greater than 0, when n greater than or equal to 0, we have yn that is equals to summation k is equals to minus infinity to plus infinity xk hn minus k. So what is the reason of overlap? So it is basically reason of overlap is from k equals to 0 to k is equals to n only. If we see the graph, if we see from the graph, previous graph, so if we see the previous graph, we can easily find out that the overlapping points are from k equals to 0 to it is k equals to 0 to k equals to n. It is from k equals to 0 to k equals to n. Okay, there is some problem. Okay, so the overlapping point is from k equals to 0 to k is equals to n. So the overlapping points are from k equals to 0 to k equals to 1. We can write it xk. What is xk? It is alpha raised to the power k uk. And what is hn minus k? It is nothing but beta n minus k u n minus k. Now because because of this uk, if we see that uk and un minus k is equals to 1. When it is equals to 1, when we have 0 is less than or equal to small k less than or equal to n, and it is equals to 0 otherwise. So these two terms are equals to 1 between 0 to when k varies from 0 to n. So k is equals to 0 to k is equals to n. Alpha raised to the power k multiplied by beta raised to the power n minus k. These two terms are remaining because uk and product of uk and un minus k is combinedly equals to that product of uk and uk minus n minus k is equals to 1 when the range of k is between 0 to n and both 0 and n are included, and it is equals to 0 otherwise. So this is yn. Now yn can be written because this beta is basically beta raised to the power n. We can separately write it outside the summation. So the remaining terms are k is equal to 0 to n, alpha raised to the power k, beta raised to the power minus k, and it is equals to beta raised to the power n summation k is equals to 0 to k is equals to n, alpha divided by beta raised to the power k. So further we can write it as basically there are two conditions. Further we have to follow two conditions. The case one is when alpha is equals to beta. So in this case that yn is nothing but summation beta raised to the power n summation k is equals to 0 to k is equals to n 1 raised to the power k. So it is equals to beta raised to the power n summation k is equals to 0 to k is equals to n 1, and it is equals to beta raised to the power n plus 1. So it is yn. So this is the case when alpha is not equals to beta and n is greater than or equal to 0. So this is the case. Now second case is case 2. In this case when alpha is not equals to beta, then yn can be written as beta raised to the power n summation k is equals to 0 to k is equals to n alpha divided by beta raised to the power k. So it can we can simplify this. We can write it as yn is equal to beta raised to the power n summation k is equals to 0 to k is equals to n alpha divided by beta raised to the power k. Now we can solve this series. So it is alpha divided by beta raised to the power 0 plus alpha divided by beta raised to the power 1 plus alpha divided by beta raised to the power 2 plus dot 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 plus what is the last term? So it is alpha divided by beta raised to the power n when k is equals to n. So it is nothing but the GP. And what is the first term? First term is 1. So 1 minus what is the common ratio? The common ratio is alpha divided by beta, and the number of terms are n plus 1, and it is 1 minus alpha divided by beta. So this is our solution. So finally we can write it as 1 divided by beta minus alpha. Please check, it is very simple to manipulate this. So 1 divided by beta minus alpha, beta raised to the power n plus 1 minus alpha raised to the power n plus 1 into un. Why? Because we are considering it for n greater than or equal to 0. Now we can summarize this. We can summarize this. So yn is equals to 1 divided by beta minus alpha, beta raised to the power n plus 1 minus alpha raised to the power n plus 1 into un when we have alpha not equals to beta. Next is beta raised to the power n plus 1 un when alpha is equals to beta. So this is our yn. So let us solve another problem. So the problem is we have a discrete time LTI system. We have a discrete time LTI system, and the input is xn and the output is yn, and the impulse response is hn. So xn is given, xn, that is input of the discrete time LTI system, it is given alpha raised to the power n into un, and hn is given, that is alpha raised to the power minus n u of minus n, and it is between 0 to is less than alpha less than 1. It is between 0 is less than alpha less than it is between 0 is less than alpha less than 1. So that input is given and output is given. So let us let us find out the solution of this problem. Let us find out that. So let us plot the xk. So how let us plot the xk. So xk is just like because alpha is between 0 and 1, so it is decreasing type. You see, decreasing. So this is plot of xk at n equals at k equals to 0. The value is 1 and it is decreasing. It is decreasing continuously. It is decreasing continuously. Then we have plot of hk. So the plot of hk, is basically hk is alpha raised to the power minus k into u of minus k. So u of minus k is equal. So what is u of minus k? So u of minus k is equals to 1 for k less than 0, and it is equals to 0 for k greater than 0. So from minus infinity to 0 the value is 1, and for all other values it is equals to 0. So it is u of minus k. This is graph of u of minus k. This is graph of u of minus k. So that hk you can we can plot is basically it is at k equals to 0 the value is 1, and for all the other values it is decreasing. It is like just behaving like that. So this is hk. So what is graph of h minus k? So what is graph of h minus k? So let us draw the graph of h minus k. So h minus k is just the mirror image. H minus k is just the mirror image of hk. So h minus k is just we have reflection, the time reversal. So it is basically the time reversal. So it is basically the time reversal of hk. It is basically the time reversal of hk. Now we have n minus k. So we have hn minus k. So when n less than 0, what is graph of hn minus k? When n is less than 0, so it is shifting in n points in the left hand side. And what is graph of hn minus k? When n is greater than 0, so it is shifted it right hand side. So it is further shifted in right hand side. So this is graph of hn minus k when n is greater than 0. This is graph of hn minus k when n is greater than 0. So let us do that. Let us do the analysis. So let us plot the required graphs. So the first graph we require is we require xk. So xk we require. So what is the graph of xk? So at graph of xk is like this. Then second graph we require is hn minus k when n less than 0. So this is graph of hn minus k when n less than 0. And what is the graph? We can see that here. We can see that. So this is our graph when n less than 0. So this is our graph. It is decreasing. So it is graph when n less than 0. The third graph required is hn minus k graph. So this is graph when n is greater than 0. So these three graphs we require. So please understand that this is n point and this is nth point. Please understand that. We don't know how much is what better to write it single. Okay, better to write it single. So this is our nth point, and this is our nth point in positive side. This is, so here the shifting takes place in negative axis, here the shifting takes place in positive axis when n greater than 0, and this is the case when n less than 0. This is the case when n less than 0. Now we can easily say that if we see these two graphs, this graph and this graph, then there is overlapping. So there is overlapping between these two when n less than 0. So xk and hn minus k is overlapping for n less than 0, and xk and hn minus k is also overlapping for n greater than 0. So in both cases we are getting overlapping. So here also we are getting overlapping when xk and hn minus k is the product is xk and hn minus k when n greater than 0. Also we are getting overlapping. So yn yn has some value for both n less than 0 and for both n greater than 0. So let us solve this problem. So for n less than 0, so when we have n less than 0, the yn is written as summation k is equals to 0 to k is equals to infinity. If we analyze the graph, what is the reason of overlap? We can see that we can find out the reason of overlap. So the reason of overlap is from k equals to 0 to k is equals to infinity. So what is the reason of overlap? It is from k is equals to 0 to k is equals to infinity. And what is the reason of overlap when we have n greater than 0? So when we have n greater than 0, the reason of overlap is from k is equals to n to k is equals to infinity. So the reason of overlap is from k is equal to 0 to infinity. And what is xk? It is nothing but alpha raised to the power k into uk, and then alpha raised to the power minus n into u minus n plus k. And please understand that the product of uk and u minus n plus k is equals to 1 when we have 0 is less than or equal to k less than or equal to infinity. It is 0 otherwise. So both these terms, the product is equals to 1. For product is equal to 1, so it is written as k is equals to 0 to infinity alpha raised to the power k, alpha raised to the power here we have missed one term. It is alpha raised to the power minus n minus k. So we have alpha raised to the power k, alpha raised to the power minus n, alpha raised to the power k again. So this alpha raised to the power n we can put outside because it is independent. So it is independent quantity. So alpha raised to the power minus n we can put outside. So it is k is equals to 0 to k is equals to infinity alpha raised to the power 2k. So we can write it as alpha raised to the power minus n summation k is equals to 0 to k is equals to infinity alpha square raised to the power k. Now we can further return it as yn is equals to alpha raised to the power minus n summation k is equals to 0 to infinity alpha square raised to the power k. Then we can write it as because it is a series GP, so it is alpha raised to the power alpha square raised to the power 0. So alpha square raised to the power 1 plus alpha square raised to the power 2 plus dot 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 up to infinity. So it can written as 1 divided by 1 minus alpha square. Please check, it is infinite GP series. So the first term is 1 and the common ratio is alpha square. So this is your answer. So this is our answer. So answer is and for this is for n less than or equal to 0. This is for n less than or equal to 0, less than 0. So this is our first case. So this is our first case when n less than 0. So yn is equals to alpha raised to the power minus n divided by 1 minus alpha square for n less than 0. Now we can find out for n greater than 0, for n greater than or equal to 0, we can find out that the region of overlap is from k is equals to n to k is equals to infinity. So it is summation k is equals to n to k is equals to infinity. Alpha raised to the power k and into 1 because uk is 1 between for this reason, and it is equals to alpha raised to the power minus n minus k into 1 because n minus k is also equals to 1 between these intervals, between these values of k. Okay, then finally what we are getting, we are getting summation k is equals to n to infinity alpha raised to the power k, alpha raised to the power minus n, alpha raised to the power k. Again we are just we can put alpha raised to the power n outside this summation because it is independent of k. So k is equals to n to k is equals to infinity alpha square raised to the power k. So finally we can write it as alpha raised to the power minus n, and it is again infinite GP, so it is alpha raised to the power 2n divided by 1 minus alpha square for n greater than or equal to 0. So let us write these two relations. So we have yn, so what is yn? So yn is equals to alpha raised to the power minus n divided by 1 minus alpha square for n less than or equal to 0, and it is equals to alpha raised to the power minus n divided by alpha raised to the power alpha raised to the power n. This is plus n, this is plus n, basically alpha raised to the power plus n is sorry for that, divided by 1 minus alpha square when n is greater than 0. Okay, n is greater than or equal to 0, it is n less than 0. Now if we combine these two terms, then yn can be written as in the form of modulus. It is written as alpha raised to the power mod n, modulus n, because for n greater than 0 we have this relation and for n less than 0 we have this relation. So better to write in this modulus form. It is yn is equal to alpha raised to the power modulus n divided by 1 minus alpha square. So this is our answer, this is our yn, this is our response of the LTI system. Okay, so let us draw the graph of this system. So when we have n equals to 0, so let us draw the graph of yn. So when n equals to 0, we have the peak, and after that it is decreasing, because 0 is less than alpha less than 1. So please check that there is it is decreasing after that, and so on. So this is our graph of yn. So this is our graph of yn. So let us do another problem. Related to discrete time LTI system. The problem is evaluate yn is equals to xn convolution with hn, where xn and hn are shown Okay, Xn and Hn are shown in figure 1, shown in figure 1 A by an analytical technique, and B, the part B, we have to solve by a graphical method. So let us do this problem. So first figure 1, we have to draw the figure 1. So the figure 1 is given as, the Xn is given, so Xn is given as, for n is equal to 0, the value is 1. For n is equal to 1, the value is 1. For n is equal to 2, the value is 1. And for n is equal to 3, the value is 1. So this is our Xn. So this is figure 1. And Hn is given. So for n is equal to 0, the value is 1. For n is equal to 1, the value is 1. For n is equal to 2, the value is 1. So this is our Xn and this is our Hn. So this is given in figure 1. Now let us solve this problem. So let us solve this problem. So the solution of this problem is, so the first part is, we have to solve by using analytical technique. So how to solve this problem analytically? So basically we can represent Xn and Hn in the form of unit sample function. So we can represent Xn and Hn in the form of unit sample function. We can represent Xn and Hn in the form of unit sample function. So how to represent? So it is represented as, so the Xn can be written as, Xn is equal to del n plus del n minus 1 plus del n minus 2 plus del n minus 3. And so basically any discrete time signal can be represented in the form of unit samples, because the del n has equals to 1 when n is equal to 0, and it is equals to 1 for n is equals to 1. So we have written this in the form of unit sample Xn. Then Hn is also can also written in the form of unit sample, can be represented in the form of unit samples. So Hn is equals to del n plus del n minus 1 plus del n minus 2. So this is our Xn and this is our Hn. So let us solve this problem. So Yn is nothing but it is convolution of Xn with Hn, and it is written as summation k is equals to minus infinity to plus infinity xk Hn minus k. So we can write it as Xn convolution with, and we can use the value of Hn given here. So this value is given as del n plus del n minus 1 plus del n minus 2. Now we can write it as yn is equals to xn convolution with del n plus xn convolution with del n minus 1 plus xn convolution with del n minus 2. So xn convolution with del n minus 1 plus xn convolution with del n minus 2 plus xn convolution with del n minus 1. Now we can apply the property that the property is we have xn, if we have xn convolution with del n minus n naught is basically the delay, so it is equals to xn minus n naught, it is equals to xn minus n naught. So we can apply this property, so we can write it as xn plus x n minus n naught, that is n naught is here, n naught is 2, so it is n minus 2 plus x n minus 1. Now what is xn? So xn is given as del n plus del n minus 1 plus del n minus 2 plus del n minus 3. So we can use the xn here in yn. So it is written as yn is equals to del n plus del n minus 1 plus del n minus 2 plus del n minus 3 plus we have this delay of n minus 1, so it will become del n minus 1, it will become del n minus 2, it will become del n minus 3, it will become del n minus 4. So finally we have this relation, so it is xn minus 1 is nothing but del n minus 1 plus del n minus 2 plus del n minus 3 plus del n minus 4 plus this xn minus 2. Xn minus 2 is nothing but del n minus 2 plus del n minus 3 plus del n minus 4 plus del n minus 5. So what we will get finally, that yn is equals to, we can write the yn which is equals to del n plus we can add the same terms, so it is 2 times del n minus 1, 3 times del n minus 2. So because del n minus 1 appears 2 times, so we have added that del n minus 1, so it will become there 2 times del n minus 1 plus 3 times del n minus 2 plus 2 times del n minus 3 plus 2 times del n minus 4 plus del n minus 5. Now if we write in simply that numeric value form, then it is equals to 1, because at n equals to 0 the value is 1, at n equals to 1 we have 2, at n equals to 3 we have 3, the amplitude is 3, at n equals to 4 we have amplitude 3, at n equals to 5 we have amplitude 2, at n equals to 6 we have amplitude 1. So this is for n equals to 0, this is for n is equals to 1, this is for n is equals to 2, this is for n is equals to 3, this is for n is equals to 4, and this is for n is equals to 5. Okay, so sorry I forget tell you that it is for n equals to 6. So we have the plot of yn, so we can plot the yn. So at n equals to 0 the value is 1, for n is equals to 1 the value is 2, the n is equals to 3 the value is 3, the n is equal to 4 the value is 3, the n is equals to that n equals to 3 the value is 3, so it is 1, it is 2, 2 it is 3, and then we have at n equals to 2 4 we have 2, the value is 2, and at n equals to 5 the value is 1. So this is yn. Now let us solve this problem using second method. Is in part B we have to solve this problem by using graphical method. So we can solve this problem by using graphical method. So let us solve this problem by using graphical method. So let us solve this problem by using graphical method. So we can plot HK. So what is HK? We can see that the HK is at n equals to 0 we have 1, at n equals to 1 we have 1, at n equals to 2 the value is 1. So this is our HK, and then we have XK. So for n equals to 0 the value is 1, for n is equals to 1 it is 1, for n is equals to 2 it is 1, for n is equals to 3 it is 1. So this is HK. Now we can see that for n less than 0, for n less than 0 the Hn minus k, for n less than 0 the Hn minus k is shifted at some value n. It is shifted for some value n. So let n less than 0 means n is equals to let it is equals to minus 1 for simplicity. So it is minus 2, it is shifted to minus 2, then minus 3, minus 4. This is Hn minus k when we have n less than 0, and for simplicity I have taken n is equals to minus 1, and this is our product of, here we have product of xk with Hn minus k when n is less than 0. So we can see that this is our xk, this is our Hn minus k when n less than 0. We can easily see that the points are, all points are 0 because there is no overlap, because there is no overlap. Okay. Now let us do for another or values of for other values of n. So let us consider n is equals to 0. So the plot of Hn minus k with k is like this. For n is equals to 0, at 0 it is 1, at minus 1 it is 1, at minus 2 it is 1. So this is for n is equals to 0, and the product of xk with Hn minus k is equals to the product of hk with xk with Hn minus k is equals to if we is equals to only one value we are getting, that is for k is equals to 0, because there is only one point at which xk and Hn minus k is overlapping for n is equals to 0. Now when we have n is equals to 1, when we have n is equals to 1, then the graph is like this. It is for n is equal to 0 it is 1, and for n is equals to 1 it is 1, and for n is equals to minus 1 it is 1. And the product of xk with Hn minus k, so there are 2 points on which the overlapping is done. So for the point is at n equals at k equals to 0 and k equals to 1, we have 1. Okay, so in this way there are 2 overlapping points. Now let us plot for n is equals to, let us consider for n is equals to 2. So this Hn minus k plot with this k, that xk with respect to kx is basically the graph is like this. So we have 1 1 1 for 0 1 and 2, and the product of xk with Hn minus k is nothing but we have three overlapping points at k is equal to 0, at k is equal to 1 and k is equal to 2. The value is 1 1 1. Now at n is equal to 3, the hn minus k plot is, it is 1 2 3. At k is equal to 0 it is 1, at k is equal to 2 it is 1, at k is equal to 3 it is 1, and it is the product of xk with hn minus k is nothing but it is equal to 1 1 1 for n, k is equal to 1, k is equal to 2 and k is equal to 3. So next is when we have n is equal to 4, when we have n is equal to 4, then hn minus k is nothing but 2 3 4. Now product of xk with hn minus k is 2 and 3. At 2 k is equal to 2 and k is equal to 3 we have 1 1. Please check. Now for n is equal to 5, for n is equal to 5, for n is equal to 5, that hn minus k is nothing but at k is equal to 3, k is equal to 4 and k is equal to 5 we are getting 1 1 1 respectively, and the product of xk with hn minus k is we are getting only 1 point at k is equal to 3. Now overlapping is decreasing. So when we have n greater than 5, for when we have n greater than 5, that hn minus k is nothing but for k is equal to 4 5 6 it is 1 1 1 and all other values it is 0, and this xk hn minus k it is 0, all zeros. So basically what we are getting that xk and hn minus k, xk and hn minus k basically they are overlapping for, they are overlapping for 0 is less than n less than 5 and for n less than 0 and n greater than 5, xk and hn minus k they do not overlap, do not overlap. So what we will get, the summary of xk with hn minus k for 0 is less than or equal to n less than 5 is y0. For n is equal to 0 we have 1, for n is equal to 1 we have 2, for n is equal to 3, for n is equal to 2 the value is 3, the n is equal to 3 the value is 3, at n equals to 4 the value is 2, and n equal to 5 the value is 1, and for n greater than 5 the value is 0. So we can plot this. So at n equals to 0 we have 1, at n equals to 1 we have 2, then we have 3, again we have 3, then we have 2, then we have 1. So this is our yn. Now we can see that for both the answer we are getting is same for both analytical and graphical approaches. The answer is same for both approach. The answer is same for both approaches. Now let us solve another problem. Let us solve another problem. So the problem is consider a discrete time LTI system whose input xn and output yn are related by yn is equal to summation k is equals to minus infinity to n 2 raised to the power n minus k into x k plus 1. This is our question. Now this is our yn. Now question is the system causal? Is the system causal? Is the system causal? So solution for this problem is the yn is nothing but this. If we put the inside the system, if we put the input at xn, the inside the system operator, if inside the system operator we put the input xn, so if xn is equals to del n, then yn is nothing but the impulse response. It is equals to the impulse response. So when we are taking xn is equal to del n, that is input is equals to del n, then output is obviously the impulse response. So the impulse response, that equation we have already given in the question, that this yn, that is equals to hn when we have xn is equal to del n. So it is equals to summation k is equals to minus infinity to n 2 raised to the power k minus n del k plus 1. Now if we solve this problem, then what we will get here is that we can apply the formula that if we have gn multiplied by del n minus n naught, that is equal to gn naught del n minus n naught. Now we can apply this formula in this summation. We have k is equal to minus infinity to n. The delay is what is the delay we are getting here is minus 1. The delay is minus 1. So it becomes minus n plus 1 because k is equals to minus 1. So we have taken the minus 1 common here. So it is equals to minus 2 raised to the power minus n plus 1 del k plus 1, and it is nothing but it is equals to 2 raised to the power minus n plus 1 outside. We can put this outside, and we have k is equals to minus infinity to k is equals to plus infinity del k plus 1. So finally what we can write it as hn is nothing but 2 raised to the power minus n plus 1 summation k is equals to minus infinity to k is equals to plus in k is equals to n del k plus 1. Now replacing let k plus 1 is equals to m. So hn will become 2 raised to the power minus n plus 1 summation. So m is equals to minus infinity to m is equals to n plus 1 del m. Now we can see here that it is nothing but u n plus 1. It is nothing but u n plus 1. So summation m is equals to minus infinity to m is equals to n plus 1 del m is nothing but u n plus 1. Please check. So the hn, hn we can write hn is equals to, the final answer is minus 2n plus 1 into u n plus 1. So the impulse response hn is equals to 2 raised to the power minus n plus 1 into u n plus 1. So this is the impulse response of our system. Now we can analyze that impulse response. So we can see that the graph of impulse response due to this un plus 1, because un plus 1 is basically it is equals to 1 for n greater than or equal to minus 1, and it is equal to 0 for n less than minus 1. The graph is like this. This is your this is minus 1, this is 0, this is 1. So this is un plus 1. This is un plus 1 graph, and so on. So this is basically that hn, basically the hn is not equals to 0. The hn is not equals to 0 for n less than 0. So this is a non-causal system, because the impulse response is not 0. The impulse response is not 0 when we have n less than 0. So this impulse response is basically that impulse response. So this is basically the non-causal signal. So this is basically the non-causal system. So this is basically the non-causal system. So let us do another problem. So the problem is we have a we have to verify the VIBO stability. So verify the VIBO stability. Verify the VIBO. Verify the VIBO stability. Verify the VIBO stability condition for discrete time LTI systems. So the solution of this problem is VIBO means we are considering that input is bounded. We are considering that input is bounded. So we have the input that is xn, and that is bounded for all value of n. For all value of n. So basically the yn, modulus of yn is equals to modulus summation k is equals to minus infinity to k is equals to plus infinity xk h n minus k. Now if modulus of yn is less than or equal to summation, it can be written as summation k is equal to minus infinity to plus infinity. Modulus of hk we can separately write it as, and modulus of xn minus k, it is equals to, because that input is bounded, because the input is bounded, it is equals to k1 summation k is equals to minus infinity to plus infinity modulus of h k. So why it is happening? Because since modulus of x n minus k is bounded, because input is bounded, so this modulus of yn is equals to k1 is less than or equal to k1 summation k is equals to minus infinity to k is equals to plus infinity modulus of hk. Now if the impulse response is bounded, if the impulse response is summable, that is k is equals to minus infinity to k is equals to plus infinity, modulus of hk is equal to k, that is less than infinity, then what we can say that then we have modulus of yn is less than equal to k1 multiplied by k, that is equals to k2, and it is bounded. So since that yn is bounded, so we can say that it is BIBO stable system. So it is BIBO stable system. So this is the condition of BIBO stability of the system. So let us do another problem. So the problem is, consider a discrete time LTI system with impulse response Hn given by Hn is equals to alpha raised to the power n un. So the first part is this system causal? Is this system causal? And the second part is this system BIBO stable? Is this system BIBO stable? So we need to solve these two problems. So basically the impulse response is alpha raised to the power n un. Now is it causal signal? Obviously, because un is equals to 1 for n greater than or equal to 0, it is 0 for n less than 0. So this is only so Hn is equals to 0 for n less than 0, so it is causal. So the first part is that it is a causal system. The second part is if summation k is equals to minus infinity to plus infinity, modulus of hk is less than infinity, that is bounded. If it is absolutely summable, then we can say that it is stable. So let us find out whether it is stable or not. So it is k is equals to minus infinity to k is equals to plus infinity, modulus of alpha raised to the power k uk. And the solution of this problem is that since uk is only defined for positive values, so from k is equal to 0 to k is equal to infinity, we can write it as alpha raised to the power k into 1. Now what we will get here? We will get that the solution of this is 1 divided by 1 minus modulus of alpha, and this modulus of alpha is less than 1. Now there are conditions. This system is BIBO stable. The system is BIBO stable if we met the following condition. So what is the condition? If we analyze that expression, we can find out that if modulus of alpha less than 1, then the system is BIBO stable, otherwise the system is not stable. So what is the condition? So the system is BIBO stable if modulus of alpha is less than 1. So this is the condition when BIBO stable system is there. And when modulus of alpha is greater than or equal to 1, the system becomes unstable. The system becomes unstable. The system becomes unstable. So this is the condition for instability. So when modulus of alpha is greater than or equal to 1, the system becomes unstable, and when it is when is modulus alpha less than 1, the system is stable. The system is BIBO stable. The system is BIBO stable. So let us do another problem. So compute the convolution sum. Compute the convolution sum yn is equals to xn convolution with hn for the following pairs of sequences. So the first part is xn is equals to un and hn is equals to 2 raised to the power n u minus n. So let us do and the second part is xn is equals to second part is xn is equals to 1 by 2 raised to the power n un and hn is equals to del n minus 1 by 2 del n minus 1. So let us compute this. So let us compute the first part, that is xn is equals to un and hn is equals to 2 raised to the power n u minus n. Let us compute this part. So what is yn? Yn is summation k is equals to minus infinity to k is equals to plus infinity xk and hn minus k, xk and hn minus k. So this is k is equals to minus infinity to plus infinity xk hn minus k. Basically we have to find out the graphs. So the graph of xk is like this. This is the uk basically. Xk is uk. Now the this hn minus k is for n less than 0. What is that graph of hn minus k for n less than 0? So first draw the graph of hk. So what is graph of hk? So hk is nothing but 2 raised to the power k into uk. So hk is 2 raised to the power k into u minus k. So it is the graph for k is equal to 0, it is 1, and for k is equal to minus 1, the graph is, because it is u minus k, it is defined only for negative values, it is equal to 1, otherwise it is equal to 0. So for n is equal to 2, so it is 1 by 2. For k is equal to minus 1, it is 1 by 4. For k is equal to, and so on. So this is graph of hk. Now the graph of hn minus k for n less than 0, so it is equals to it will shift in more in negative direction. So it is just like this. Now for n greater than 0, for n greater than 0 it will shift at some point. So let it is we are considering here n is equals to -1, so it is shifted some point n. Okay, it shifted at some point n in negative direction. I have drawn the wrong graph, sorry. So let us draw again. I did some mistake here. So hn minus k for n greater than 0, the graph should be like this. So this is graph for hn minus k when n is greater than 0. Now we have to find out the value of yn. So for let us solve this. Let us solve for n less than 0. So yn is nothing but the range will become k is equals to 0 to n only, because this is the only values of k in which xk and hk n minus k will overlap, and it is equals to 2 raised to the power n minus k only. So it is 2 raised to the power n summation k is equals to 0 to k is equals to n 2 raised to the power minus k, and it is equals to 2 raised to the power n. So we can solve it. 1 minus 1 by 2 raised to the power n plus 1 divided by 1 minus 1 by 2. So finally, after solving this, the solution of this problem, after solving this, what we will get? We will get 2 raised to the power n, 1 minus 1 by 2 raised to the power n plus 1 divided by 1 by 2. So this 2 will go upward, and that final solution for this is what we will get. We will get that it is equals to so we can solve it. So this is 2 raised to the power n plus 1, 1 minus 2 raised to the power minus n plus 1. What is the solution of this problem? We can we can put this inside that. We can put this inside that. So what we will get? We will get. So because it is the finite, this is finite number of terms. So okay, this is simplified form. We can further simplify it. We can multiply this inside, and we can further simplify. Okay, now consider the case when n greater than 0. So consider the case for n greater than 0. Now for n greater than 0, so for n greater than 0, what is happening that we have yn is equals to, so what is the range for overlapping range? It is n to infinity only. Okay, 1 into 2 raised to the power n minus k. So what we will get here, we can put 2 raised to the power n outside. So it is k equals to n to infinity 2 raised to the power minus k, and the solution of this is 2 raised to the power n multiply 2 raised to the power minus n divided by 1 minus 2 raised to the power minus 1. So the solution is 2 only. What we will get? We will get here for n greater than 0 we have 2. For n greater than 0 we have 2. So this is our solution. Now comes to that another part, that is B part of the problem. So in B part, what we have in B part, that xn is given, and what is given, what is the value of xn? So the xn is nothing but 1 by 2 raised to the power n un, and what is hn? Hn is del n minus 1 by 2 del n minus 1. So what is yn? Yn is nothing but convolution of xn with hn. So we can put the value of Hn here, that is del n minus 1 by 2 del n minus 1. We have used this 2 here. Now x and convolution symbol is there. So xn convolution with del n minus 1 by 2 xn convolution with del n minus 1. Now what is that? It is xn only, and it is 1 by 2 xn minus 1. Now what is our aim? Our aim is to find out the what is our aim? Our aim is to find out the value of yn, but xn is also given. So putting the value of xn here, so what we will get here? We will get, instead of xn, we are putting the value of 1 by 2 raised to the power n un, and what is the value of this 1 by 2 xn minus 1? So it is 1 by 2 we can put outside, so it is 1 by 2 n minus 1 u n minus 1. Now we can take n common, so it is un minus un minus 1. So it is nothing but del n. How it is del n? It is very simple to interpret that. So this is our un. Now there is another value that is minus of un minus 1. There is another value that is minus of nu minus 1. So all these things will cancel out. So this is cancel out. So what is it will remain? Only first term. First point is remain at n equals to 0. It is equals to 1. So it is nothing but del n. Now again applying the property here, we will get 1 by 2 raised to the power 0 into del n. It is del n only. So the solution of this problem is del n. Okay, so we have find out that the impulse response, the response of the system is nothing but del n. So basically the response of the system is yn is equals to del n here.